All right, in this video we're going to look at the yellow part of your rainbow review. So looking at this first question, it says a multiply or divide, so we want to make sure that we check to see what are we actually doing. So because if we're dividing, it means we have to do something slightly different. So this first one we're multiplying, and so the first step is to make sure that we have everything in factored form. So there's nothing I can do with the first fraction, so we'll have 1 over x plus 4. But that second fraction, that numerator, we can simplify that, because I see that 6 goes into both 6 and 24 evenly. And then before we actually multiply those together, the next step is we want to, I like to look to see if we need to state any restrictions in our domain. So in our domain, our restrictions is that x can't equal, for this first factor, x can't equal -4, and the second factor, x can't equal -9, because otherwise you'd have 0 in your denominator. So it's always good to identify that first, and that way you don't forget about any of those that might cancel out. Because what's going to happen here is the x plus 4 and the x plus 4 cancel out, leaving us with just 6 in the numerator and x plus 9 in the denominator. So that would be the simplified form, with this being the restriction in your domain. All right, let's look at number 2. So for number 2, same deal. We want to first look and make sure that all we're doing is multiplying here, so we don't have to do any extra steps. But the first fraction, there's nothing I need to simplify there. So we're going to have 4 over x plus 4. But the second fraction, both the numerator and denominator, we can factor those down. So the first thing I'm going to do is in the numerator, I'm going to look at factoring that. So I recognize that our a value, our leading coefficient, is 1. So we can do this shortcut way without having to use the box method. So I'm trying to find two numbers that multiply to be 20 that add together to be 9. And that would be 4 and 5, because 4 times 5 is 20, and 4 plus 5 is 9. In the denominator, I see that everything's divisible by 4, and I also see that we have at least an x squared there. So I'm going to factor out a 4x squared, and that leaves me with x minus 6 in the denominator. Okay, so before we do anything else, we want to identify any restrictions in our domain. So looking at this first factor, x plus 4, if I set that equal to 0, I would find that x can't equal -4. If I set this factor equal to 0, I would just get 0. So x can't be 0 either. And if I set this factor equal to 0, I would get 6. So x can't be 6 either. So there's 3 restrictions in our domain. All right, so now, like I say, I always like to do that first before simplifying, so I don't forget any of those restrictions after I cancel things out. As far as canceling things out, the only thing I can do is x plus 4 cancels out of both of those. So we're left with, and then the 4's cancel out too. So we're left with x plus 5 in the numerator over x squared times x minus 6. And then we would have this restriction in that domain. All right, let's look at the last one, number 3. Now the one thing I recognize with this one that's different from the other two is this one we're dividing. So remember, we can't divide by fractions, we need to change it to multiplication. But first, let's start with that first fraction. I'm going to factor that down. Again, my leading coefficient is just 1, so we can use this shortcut method. So I'm trying to find two numbers that multiply together to be 45, that add together to be -14. Well, that's going to be -9 and -5, because -9 times -5 is a positive 45, and -9 plus -5 is a -14. In our denominator, we would just have 8x squared. Now, to change this to be multiplication, remember we have to multiply by the reciprocal. So that x plus 6 would go in the numerator. In the denominator, we're going to factor down that x squared minus 3x minus 54. And when I do that, I would get, so again, we're trying to find two numbers that multiply together to be -54 that add together to be -3. Well, that's going to be -9 and a positive 6. Because -9 times 6 is -54, and -9 plus 6 is -3. So before we restrict, or before we do anything else, I'm going to find what restrictions we may have in the domain. And if I set this factor equal to 0, I would just get 0. Because if I took 0 divided by 8, I'd get 0, and the square root of 0 is just 0. This one, if I set this equal to 0, I would get 9. And then this one, if I set that equal to 0, I would get -6. So my restrictions are that 0, or x can't equal 0, 9, or -6. All right, but now let's look to see what we can cancel out here to make this simpler. I see that we have an x minus 9 in both of those, so we cancel those out. I see that I have an x plus 6 and an x plus 6 here. And so all we're left with is x minus 5 over an 8x squared. And that would be the simplified form with this restriction in our domain. So that's how you do the front side of the yellow. Let's look at the back side. So for this one, we're going to just look to see for number 4 on the back, or for some of you guys it might have been number 1. But we're going to look for the least common multiple. So the first thing I got to do is I have to make sure everything's in factored form. So this one, I want to factor that down to be x, because we're trying to find two numbers that multiply together to be negative 15, that add together to be negative 2. So it'll be a negative 5 and a positive 3. So then I look at, all right, what's our least common multiple supposed to be? The phrase I like to use is I want to make sure that every factor is represented. So in this, let's just look at this first one, or the second one here rather. I have x minus 5 and x plus 3. Then I look at this one over here. And that one, the x minus 5 is already represented, so we don't need to represent it a second time. So I want to make sure that every factor is represented, and so every one is. And so our least common multiple would be x minus 5 times x plus 3. All right, now this one, both of these can factor. X squared minus 4 is a difference of squares. That factors down to be x plus 2 times x minus 2. This second one factors down to be, because this is also one of these easy ones where we have a leading coefficient of just 1, so we can use a shortcut method. So we're trying to find two numbers that multiply together to be negative 6, that add together to be a positive 1. And so that would be a positive 3 and a negative 2. So 3 times negative 2 is negative 6, and 3 plus negative 2 is positive 1. So to find the LCM, want to make sure that every factor is represented. So I'm going to start with that first set. So we have x plus 2 times x minus 2. I look at that for the second set. X minus 2 is already represented, so we don't have to represent it a second time. But x plus 3 needs to be represented, so I need to write that down. So again, the phrase I like to use is that every factor needs to be represented. All right. There's a typo here. It should be simplify, but we're going to add or subtract and simplify your answer possible, and the denominators can be in factored form. All right, so anytime I see subtraction, I want to change that to adding a negative, and it's a negative to that entire numerator, not just the x. So you're going to just end up distributing that negative through. So this is going to actually become negative x plus 3. So that's one thing I like to do. As soon as I see that we're subtracting two fractions, change it to adding a negative. All right, let's look at the denominators. We need to figure out what our LCM is going to be to have a common denominator here. So the first fraction there in that denominator, I'm just going to rewrite that numerator. We would have, that's a difference of squares, so that would be x plus 4 times x minus 4. Plus, and then we have a negative x plus 3 in that numerator. And our denominator, that can also factor. That's going to factor down to be, because we're looking for two numbers that multiply together to be 16, that add together to be 8. Well, that's just 4 and 4. So 4 times 4 is 16, and 4 plus 4 is 8. All right, so now I want to figure out, well, what's my LCM going to be? So I see in that first fraction, we're going to have x plus 4 times x minus 4. The second fraction, I have x plus 4 and an x plus 4. So I have two of the same factor in that same expression, in that same denominator. So I need to add another x plus 4 here. So we're going to have, it doesn't matter what order we put those in, but we are going to have x plus 4 times x minus 4 times x plus 4 as our LCM. So now in that first fraction, what are we missing? We're missing another x plus 4. So we're going to multiply that first fraction in the numerator and denominator by x plus 4. The second fraction, we're missing an x minus 4. So we're going to multiply this. Remember, that's a negative x plus 3. We're going to multiply that times x minus 4. All right, so now let's go ahead and, so now in the next step, I'm going to write this as one giant fraction, because we're going to have the common denominator now of x plus 4 times, I'm just going to write it this way, x plus 4 times x minus 4. Again, it does not matter what order we put them in. But in that numerator, let's first multiply those together. Now, if you're to multiply those together using the box method, or you could FOIL it, you're going to end up getting x squared plus 6x plus 8. And then the fact that I already distributed the negative through makes this easier. So I'm going to multiply the negative x times x. That'll give me a negative x squared. And then if I FOIL the rest of it, let's see, I'd have a positive 4x and a 3x. This would be plus 7x. And 3 times negative 4 would be negative 12. So I FOILed it, just makes it a little easier. Okay, so now we're going to simplify that numerator. That's my next step. So when I simplify the numerator, I notice that x squared minus x squared, that's 0. That cancels out. 6x plus 7x would be 13x. So I'm done with those. And 8 minus 12 is negative 4. So we'd have 13x minus 4 in the numerator. The denominator, we can leave this in factored form. So it would be x plus 4 times x plus 4 times x minus 4. Or whatever order you have those factors in is fine. So that would be your final answer. So a lot of work for number 6. Let's look at number 7. So here we're just adding, so it makes it a little bit easier, but we do have to factor each denominator because those can be factored. So this one here, we can factor out an x. We'd have x minus 3. Can't do anything in the numerator. It's supposed to be a 7 here. But the denominator, it's one of those that factors. So we're trying to find two numbers that multiply together to be negative 12 that add together to be a positive 1. So that would be negative 3 and a positive 4, because negative 3 times 4 is negative 12, and negative 3 plus 4 is 1. All right, so the next step is to figure out, well, what's our least common multiple going to be? So I see in that first fraction we have x times x minus 3. I want to make sure every factor is represented. And then in the second fraction, I already have the x minus 3 here, so I don't need to include it again. And then we have x plus 4. So that's what our LCM is going to be. So in the first fraction, we're going to multiply everything by x plus 4 in the top and bottom. Second fraction, we just need to multiply the top and bottom by an x. So what you end up getting in the next step, if we write this as one giant fraction, where we have our LCM, which would be x times x minus 3 times x plus 4. Again, any order would be fine. Our numerator, we're going to distribute the 5 through. So we would have 5x plus 20 for that piece. Here we're going to distribute the x. So we would have plus x squared minus 7x in the numerator. So now we want to combine like terms to get our final answer. So x squared, let's just start with that. There's no other x squared. 5x minus 7x is negative 2x. And we have plus 20. And then we would have x times x minus 3 times x plus 4. And since x squared minus 2x plus 20, that can't be factored, because we'd be looking for two numbers that multiply together to be a positive 20 that add together to be a negative 2. And the only factors of 20 that we would have, so they both would have to be negative since they multiply together to be a positive and add together to be a negative, are negative 1 and negative 20, but those don't add up to be negative 2. Negative 2 and negative 10 don't add up to be negative 2. And negative 4 and negative 5. Those multiply together to be 20, but they also do not add up to be negative 2. So that can't be factored any further. So this can't be reduced anymore. So this would be your final answer for that last problem in this yellow section.